Okay, MCT4C, day 69. This is the first day in uh, kind of the second half of chapter 7, which is all on circle stuff. And so we're going to learn a lot of new terminology today, but we're going to base it. I'm going to go back to stuff that you already know about the circle, so it shouldn't be too bad. We're starting in the 3-minute review to find the perimeter and area of each of these figures. And this is just a chunk of a circle. This is a quarter circle, isn't it? Right? It's a quarter circle. So the perimeter is just the two lengths plus the curved part, right? And the curved part there is a quarter circle, and I'm going to do that over here. So curved part is the diameter, or pi times the diameter is the circumference all the way around a circle's their circumference, and then all we have to do is divide that by 4. And that is pi times the diameter is 6 divided by 4 is about 4.7 inches. And that's 6 plus 4.7 inches, which is about 10.7 inches. The area, same deal, just a quarter circle, right? So it's a circle, pi r squared, and then divide by 4 at the end, because it's a quarter. The radius is 3 squared divided by 4, which is about, put that into a calculator in one step, pi times 3 squared divided by 4, about 7.1 square inches. No problem, changing color. This one's a harder one. The perimeter isn't so bad. The perimeter is just, if I'm starting here and walking around the outside, I've got these 3 lengths, right? 3 times 4 plus the curved part, right? Now the curved part in this one's a little more challenging, right? Because it's, over here I just divided by 4 because it was a quarter of a circle, right? Well, what fraction of a circle is a 60-degree angle? Because that's what fraction of the circumference I have. So I know this is going to be pi d divided by something, but what fraction? Or I could multiply by the fraction. Well, 60 degrees over 360, that's 1/6. So that means that this is 1/6 of a circle. And maybe some of you knew to divide by 6, but that's the curved part here is just going to be 1/6 times pi d. Or notice I could divide by 6 in that one. That would be fine as well. And I'd have about 4.2 centimeters. 16.2 centimeters. D, by the way, notice D is 8 here, right? D equals 8 because half of this is the radius, where this is the center of the circle, and this is a piece of the outside of the circle. So the diameter is 8, the radius is 4. The area is a little more challenging still, but let's get at it. So I can see it's the triangle at the top. The area is area of the triangle plus the area of this pie shape. Okay? And this is actually going to take a little bit of work. So we've got a few minutes. Why not? The triangle, notice, it's actually an equilateral triangle. Hopefully you notice that. So these are each 4. But how do I know what the height is? So the base is, oops, the base is 4, but what's the height? Well, let's think about this. Notice that this is this half triangle. This is 4. This is a 60-degree angle. That's a 90. This is 2 because it's cut in half, and I want to know the height. I want to know what that is. 60-degree angle is one of our special triangles from the trig unit. Note to self, study for the exam, right? This is a special triangle. It's this triangle. It's this 1, 2, square root of 3 triangle. Notice that this is just this one doubled, right? So this is, I just multiply by 2 here. So what's the height? The height is 2 times the square root of 3 exactly. Now, yes, I will just fire this into a calculator in a minute, and don't get all worried about that. Running out of room here, though, unfortunately. I'll just put the answer over here. The area of the triangle, put that 4 times 2 divided by 3, 4 times 2 times the square root of 3 divided by 2, or notice the 2's will actually cancel out there. I get around 6.9, and that's centimeters squared. And then the sector, this pie shape is called a sector. The pie shape is, we said that that's 1/6 of a circle. Now I'm running out of room here, running out of rough work to do here. The pie area of the pie shape is just pi r squared, and we determined earlier that it was divided by 6, so then it's not so bad. The radius is 4, and I get that to be about 8.4. Again, bash that into your calculator and I can add the 2 up. That's a pretty good area question, I'd say, for a 3-minute review. That took almost 7 minutes. Let's get on with the lesson. The lesson is all about these bits and pieces of a circle. There's a nice picture there. Properties of the circles, and we said recognize and describe arcs, tangents, secants, chords, segments, sectors, central angles, and inscribed angles. Some of these are familiar, some of them aren't. This is bits and pieces of a circle. And this diagram here, hopefully it photocopied well for you, but you can always look them all up, are just helping us remember what these bits and pieces of the circle are called. Some of them we know. Circumference is all the way around the outside. Diameter, radius, we all recognize those. A tangent is this special line that goes up to a circle and touches only on one spot. That's a tangent. A sector, and it says, hopefully you can read it, it says the area enclosed by an arc and 2 radii. Well, it's a pie. This is what we were talking about. This is a pie chunk. It's a piece of pie, where that is an arc. There's an arc, and it says it's enclosed by an arc and 2 radii. The plural of the word radius is radii. So there's a radius and there's a radius, and the area in between that and the arc is called a sector. An arc is a part of the circumference, any part of the circumference. So up here, or back on the 3-minute review, this was an arc. This is an arc. Any piece of the circumference is an arc. It's not like a Noah's boat. That's a different arc. A chord, it says it's a straight line joining any 2 points on the circumference of a circle. So there's a point on the circle, there's a point on the circle, that's a chord. Say, well, hang on, we knew about that before. That one right there. By the definition, that's a chord, but you called it a diameter. Well, a diameter is a special version of a chord. So this purple line is actually a diameter because it goes through the center, but a diameter is just a special chord that goes through the center of the circle. A segment is the area inside a circle enclosed by an arc and a chord. So a segment is kind of like a sector in that it's a chunk of a circle lopped off. So it's the chunk of a circle lopped off by a chord, where a sector is a piece of pie at the center. One more picture with a couple more definitions. We can see that we're familiar with this. An arc is just a part of the circumference. A central angle is an angle at the center of the circle. So notice that this would be a central angle. This would have been a central angle. In fact, there's a whole bunch of central angles there. Any angle that's at the center of a circle. An inscribed angle is an angle that has the 3 points all on the circumference of the circle. And the word that we use is that an inscribed angle is subtended. There's a great math word. Subtended by an arc or even a chord. So we could say angle ACB is subtended by arc AB, or even, if I so desired, chord AB. Okay? I'm going to pick up the examples in part 2.